Good day everyone, I'm Carl A99. Today, we delve into the world of multiple regression, a powerful statistical tool used to understand relationship between multiple variables. I'm here to teach you how to do and analyze the multiple regression using the Microsoft Excel. Okay, let's go! So now we are here. The first thing to do is to find the dataset for the multiple regression. I have an example dataset for about the life expectancy, and if you want to find a lot of examples, you need to go to the kaggle.com, visit kaggle.com, and next then you need to download and extract. So I have already downloaded the dataset, so open in the Excel. So here is the dataset of the life expectancy. As you can see, it's a lot of data. So the next step is to find the dependent variable and the independent variable. So the dependent variable is the outcome we're studying, in this case life expectancy, and the independent variable are the factors we may suspect influence the life expectancy. So I want to get 32 data for the dependent variable. Control C, put to the sheet 1, Control V, copy, and another 32 for the independent variable. Another 32 for the independent variable. Control B. So here we only have one dependent variable and two independent variables. So our dependent variable is life expectancy, and the two independent variables are the adult mortality and infant deaths. So next step is go to the data, click the data and find the data analysis. So here, is the data analysis. Click and find the residuals. Regression. Sorry. So here, input y range. So our input y range is our dependent variable, and our x range is the adult mortality and the infant deaths, the two independent variables. So we must click this and drag down for the input x range with the two independent variable. Drag down, and so don't forget to check the levels, the output range for the range, and also the residuals. So here, we're to put the summary analysis of the data. Okay, click OK. So here we have the R square 0.97. So the next step, we must go to a chart to get the actual graphical of our data. Set. Yes. But before that, we must get this in order to get the graphical data. So here, if you want to add trend line, you must to click right click and add trend line. linear, another trend line. So here, next step, get the intercept. Intercept the slope 1, slope 2, the R squared, the regression model, and the interpretation. For the observation of the data. So we have the intercept, which is a dependent variable. Enter 75. We must use equal sign to get the intercept. Enter. So here, the same pattern for the slope 1, which is ang independent variable, adult mortality. Click and enter. For the slope 2, the same pattern, infant death, which is ang independent variable. Click enter. For the R squared, we have the 0.97 equal. Click and enter. For the regression model, by the way, we must to get the first percentage of the R squared. So in order to get that, we must to use the equal sign, click the R squared, and we must to times it to 100. So this, to get the final, we must to run up this R squared. So here is the final 98. For the regression model, we have the formula y equals BO plus O plus B1, the B1, capital B1 times X1 close parenthesis plus open parenthesis B2 times X2. So here X2. So here, it's the formula. Y equals to our BO, which is our intercept. Click. Wait. No, you must copy this because it causes error if we want to click. And plus close parenthesis our B1, which is ang atong slope 1, 0.00337 times na to 2x1 close parenthesis plus our B2, which is ang atong slope 2, so negative 0.2305 times na to og x2. For the interpretation, so for this interpretation of our data set, the value of R squared is 0. So the value of data is the 0.00337. 97. Dari. Kani. 0.97. Therefore, the value of this data, by the way, we must do the kani. Narade. So for this interpretation of our data set, the value of r squared is 0.98. Narade. So for this interpretation, the value of our data set so for the interpretation of our data set, so our r squared is 0.97. So therefore, this value is generally considered strong effect size. Okay, greater than 0.7 man siya, which is 0.9. So atong value kay considered strong effect size. Next step, we must to get the predicted life expectancy and the residuals. So in order to get that, we must to use this formula. Ay para ma-get siya. So here, to get the residuals and the predicted life expectancy. So first, we must to cos our intercept, which is ang kani. Cos to intercept plus RBO plus RBO. Outside. Let's see. Plus R equals to intercept plus RB1, which is ang atong slope 1 kani. But na kani times na to og x1. Ang atong x1 kani ay 236. So close parenthesis plus open parenthesis b2, which is ang atong slope 2 times na to sa atong x2, which is ang kani x2 niya, close parenthesis. Before that, we must to lock this fn for fn and f4 lock. Enter. So here, as you can see, we get the predicted life expectancy, which is ang naguna 61.9182. Yeah, I drag it down. I simplify, drag it down. So here we get this the last number data. And in order to get the residuals, we must subtract the actual data to the with the predicted life expectancy in order to get the residuals equals to actual data present ni 65 subtract na to the left. So here as you can see we get na sakto siya, and I simplify, drag it down. So here, and if you want to find or if you want to get the actual data of the this data of this life expectancy, we must to add these two, which is ang atong predicted life expectancy and the residuals. I-add rin na to. So equals, we must use equal sign and click the right, the life predicted value and the residuals. Plus na to, plus the residual. So kani so as you can see we get the actual. I drag it down. So here correct sa sakto siya. So this is the final regression of our data. So here that's all. Thank you.